So in this video I'm going to be going through two fairly quick examples of how we solve by completing the square. In the previous video we went through sort of how this works, and this is just supposed to be two examples so you can really see just the mechanics of how it works. So here's our first example. I want us to solve the equation 0 equals x squared minus 6x minus 15 by completing the square. Okay. So our first step here is we really do want to have the x squared and the 6x terms isolated. So your first step is to add that 15 to the other side. So we'll end up here with x squared minus 6x, and I'm going to sort of leave a blank space, equals positive 15. We know that's what's going to happen when we take this 15 and we add it to both sides of the equation. Right? The next step is we know that if we want to complete the square, I'm going to need to add some very specific number to both sides of this equation. Right? And that's what was really talked about in the previous video and what we talked about during class. So how do we find that number? Right? We find that number generally by taking half of the middle term, which we know is negative 3, and squaring that. Right? So 9 is going to be the number that completes the square here. But because I'm adding 9 to the left side of the equation, I have to add 9 to the right side of the equation as well. Right? Now that I've done that, the left-hand side of my equation is x squared minus 6x plus 9. And the right-hand side of my equation, I can add those numbers together to get 24. Now the left-hand side is supposed to be, this is now a perfect square. I can write this in its factored, in its binomial squared form, and it always uses this number, this half the middle term number, that negative 3, that's going to show up here. We're going to have x minus 3 squared equals 24. And from this point on, all I'm doing is using the method of solving by square roots. It's a very straightforward process. If you understood what we've been doing in class the last 2 days, this really should be simple. Right? So our next step in solving this is to square root both sides. When I square root a variable term like this, I end up with the absolute value of x minus 3. On the right-hand side, I have the square root of 24. If that was a perfect square, we could write down what it is, but since it's not, we'll need to break down what 24 is. We'll have to factor 24. That's 4 and 6. The 4 is 2 and 2. The 6 is 2 and 3. You'll remember before that what we're looking for is we're looking for groups of two 2's, because these 2's are actually square roots. When I multiply two square roots of 2 together, I'll get a real whole 2. These numbers, these square roots don't have a pair, so we have the square root of 2 times the square root of 3, which gives us the square root of 6. And you'll notice in this next step, I think this is really important, you'll notice I'm not going to write plus or minus. I really feel like plus or minus does everyone a disservice. At this point, we have an absolute value equals a number. That means that the factor inside of this thing, the x minus 3, that must be equal to negative 2 root 6, or that factor must equal positive 2 root 6. And I'd really like us to get away from using plus or minus. I feel like it confuses matters, and I'd rather we just not use it. So we do that. Our last step is solving for x by adding 3 to the other side. 3 minus 2 root 6, and then over here x equals 3 plus 2 root 6. Those are my two solutions to the original equation that was given. In the second example, the wording is a little bit different, but you'll find it's the same thing. This question is asking us to find the zeros of the function g of x equals x squared plus 10x plus 97 by completing the square. So the first thing we need to do is we understand what does it mean to find the zeros of a function. We know that finding the zeros of a function means where the output of the function is 0. In other words, I need to solve the equation x squared plus 10x plus 97 equals 0. I want the output of my function to be 0. I'd like you guys now to pause the video and work through the method of completing the square. Follow the same steps we did in the previous one. If you're worried about it, unpause and play the videos you're going through and just make sure you're getting a chance to see that you're getting it right. So the first step from previously is we're supposed to isolate the x squared and x terms. So I get x squared plus 10x equals negative 97. And then we write in our blank space on both sides so that we remember to add it to both sides. And some of you may decide to skip that step. Please don't. It takes like 2 extra seconds to write plus blank on both sides of the equation, and it really helps for you to not forget to add it to both sides. Next up, half this middle term is positive 5. So when I square that, I get 25. And 25 is the number that's added to both sides of the equation, so that I can get this to work out nicely. So I can get my perfect square trinomial. So the left-hand side is x squared plus 10x plus 25. The right-hand side, we have negative 97 plus 25. That's negative 72. The left-hand side, because we completed the square here, we automatically know this is going to factor as x plus 5, using this plus 5 from here, equals negative 7, squared, equals negative 72. From this point, I just need to use the method of solving using the square root. If you didn't get this far on your own, if you haven't done this part, pause the video, try this again on your own. Making sure that you can do these on your own is very important. It's great that I can do it. It's you guys that need to be able to do it. So next up, we square root both sides. On the left-hand side, we get the absolute value of x plus 5. On the right-hand side, I'm going to need to look at my factor diagram for 72. 72, if we do this carefully, 72 is 36 and 2. 36 is 6 and 6, and right there we can see 2 square roots of 6. We can tell right away this is going to be 6 times the square root of 2. But remember, because our original our original term was negative, this is actually going to be imaginary. We're going to have 6i times the square root of 2, and we tend to write that I between the number and the radical. Right? Now that we have that, we remembered that an absolute value always gives two answers. We will either have x plus 5 being equal to negative 6i root 2, or we'll have x plus 5 being equal to positive 6i root 2. And again, please don't write those with plus or minus. We would be much, much happier if you wrote them as two separate terms. X equals negative 5 minus 6i root 2, or x equals negative 5 plus 6i root 2. And these are the zeros of the function that was given.